Alright, I forgot to turn the record button on the second part, so I don't know where I was at the end of the first part, but I have finished row echelon, reduced row echelon form, and if you get the zeros, I think I was somewhere around here, I was trying to get the zeros above this one, and I ended up adding these two rows and replacing this one. And now you can see that 1, 0, 0, 0, 1, 0, 0, 0, 1, that's the multiplicative identity, and that was my goal, to get the left side to look like the right side when we started. The right side looks like that, and now that looks like the left side. When I do that, what remains here is the multiplicative identity. So let's see if it really is. So I'm going to take our original problem, 1 minus 1, 0, 1, 0 minus 1, 6, minus 2 minus 3, and multiply it times what I claim is the multiplicative identity. It's what all our hard work yielded anyway. Alright, so when I multiply these together, let's see what I do get. It's a 3 by 3, so we're going to get 3 by 3 as our answers. So those are all the spots to fill in. So the first row, first column, well, it's this row and this column, 1 times minus 2, I'll jot it down, minus 2, minus 1 times minus 3, and 0 times anything is 0. So minus 2 plus 3 gives me a 1 in that position. Let's just check a couple more. I don't want to do all 9. You'll just have to trust me. Let's do this one. So we're expecting a 0 there. It's in the first column, but the second row. So it's going to involve this row, second row, and first column. 1 times minus 2, 0 times minus 3, and we're adding these plus a minus 1 times a minus 2. And that does give me 0. Let's see if we get a 1 like we're supposed to in this position. So that's second row, second column. So we'll see if it really does come out to that. So we're going to use this row and this column. 1 times minus 3 plus 0 times anything plus negative 1 times negative 4. So minus 3 plus 0 plus 4 is a 1. So if you check that whole thing out, you will see that you do get the identity matrix. So this must be the inverse. So you'll be asked to take 3 by 3s like this and find the inverse. And before I leave you sweet people, I want to show you how to find the inverse of a 2 by 2. Somebody noticed there was a quick way to do that, so let's do one. Say A equals 3 minus 1, negative 2, 2. And I'm going to teach you how to find the inverse, often indicated by A with a negative 1 exponent, meaning A inverse. The inverse of matrix A involves the determinant, and it's always going to be 1 divided by the determinant, and we'll get that in a minute, and times the matrix in a special order. Instead of having the 3 and the 2 here, these are exchanging places. So 2 and 3 have exchanged places. 3 was here, and then 2 was here, and now we've switched them. These two elements do not switch places, but they switch signs. So this one's negative, it becomes positive. This one's also negative, it becomes positive. All right, what is the determinant of this? I'm going to rewrite it since those arrows are kind of in the way. So what is the determinant of this? 6 and a negative 2 will add up to give me a 4. So A inverse is going to be 1 over 4 times that switcheroo matrix. And now we just have to multiply each element by 1/4. 1/4 times 2 is 2/4. I'll reduce to 1/2. 1/4 times 1. 1/4 times 2 again. And 1/4 times 3. So, believe it or not, this is the multiplicative inverse, the inverse matrix of this original one that we started with. If you multiplied this times this the way you have been shown, let's see, 3 minus 1 minus 2, 2, it times what we claim to be the inverse matrix, we should get the identity. And the identity for a 2 by 2 is cut a little short, but it looks like this. If you multiply these out, you'll see that these do create those. We'll check this one. 3 times 1/2 is 3/2. Minus 1/2, minus 1 times 1/2 is minus 1/2. So 3/2 minus 1/2 is 2/2. So we get 2/2 is 1. And if you check all of the matrix multiplication, you'll see that this does come out. And this is actually the inverse, the matrix inverse. So, can you carry that in your sweet little heads until tomorrow, where we will take inverses of 3 by 3s and 2 by 2s. Pretty exciting stuff. I hope you're able to sleep with all this excitement. All right, we will gather in the morning and show me your notes. If I don't ask for them, please volunteer them. And I will see you then. Bye-bye.